obtain Lorentz series of this massive function. Wait a second, camera is cooked now. So yeah, f of z equal to this big function where the radius different in different radius. Let's first the first step in this is doing partial from functions. That is the first step common to all. Then we will do it individually. Okay. By the way, I have to also show you something, right? 1 plus x raised to n. Okay. So there are two formulas you have to remember basically. 1 plus x raised to minus n. Oh, sorry. 1 plus x raised to minus n, 1 minus x raised to minus n is 1 1 x raised to 2 x cube x raised to 4 x raised to 5 x raised to 6 sorry x raised to 5. Hey, wait a second, what did I do just now? Yeah, x raised to 5 x raised to 5. So this goes on, like this is power increasing. Okay, so here it, since these are opposite signs, we would write these are opposite signs, so we would write minus plus. We would do alternate signs. Whenever in the series you see minus, no, it won't be totally minus, it would be minus plus. Since minus minus same sign, so let's give all positive. For this is for remembering, not exact things. Okay. So now let's start doing partial fractions. In partial fraction, we have to do 4z plus 3 by z into z square. Wait a second. What? Oh, sorry. No, no. Question has error. Z square. Okay. Z square to z square plus 4z plus 3 is equal to a by z plus. Now we have to first break this down. So you have to factorize. So I told you how to factorize. Like there is ax square plus bx plus c. So b1 plus b2 should be equal to b, and b1 into b2 should be equal to a into c. So break this b into this. So when we break this b, so b1 plus b2 is b. So original question is same. So the question isn't broken. So it is just divided, so we can add it again later on and it would become our original question. And ac when we multiply, which is equal to b1 into b2, then we can separate them and take common factors. They would have common factors and we can take them out, right? A something and that something, then we would take two common factors out as one and other would be multiplied, because 2x plus 4x is equal to 2 plus 4x is equal to 6x. So this works like a unit. Like let's say you are adding 2 meter plus 3 meter, you write 5 meter. Bro, it can, if you take centimeter, then the things everything change. It becomes 100 into 100. Then nothing is fixed. So but you add them, no, because meter is say unit is same, variable is same. So this coefficient is multiple of variable. So if the same variable is getting some multiples, then we can add the coefficient and that much multiple the variable would be. Simple. So we have to break it such. So let me show you how to do that in this question. Okay. So 4 can be broken into 4 can be broken into two types, -1 and +1. So that we can do +2 +3 also, but that would be more complicated. If you don't find it in -1, then you go ahead. Okay, so 3 plus 1 is also 4 and 5 minus 1 is also 4. But here don't see 5, we see 3. So it is nearby 3. See, in C it is 3, in A it is 1. 3 1 done. Like if I multiply C, which is 3, and A, here is nothing, so it is 1, because 1 into something is that only. So 1 and 3, that is multiplicative identity. That's why if you take something one time, add something one times, it is that only. So understood. So z square, so here a is 1, c is 3, a is 1, c is 3. If I multiply 3 into 1, it would be uh, uh, yeah, if I multiply this 3 into 1, it would be equal to 3 into 1 here, and 3 plus 1 would be 4. So it perfectly matches our condition. Z square, then this would be z square plus z plus 3z plus 3. So if we do z plus 3z, we would get 4z, because z only increases. It is like number, we just add, right? Because this is something and we are just adding it, because bases are same, so variable is same. It is like index, right? So so question didn't change, because 3z plus 4z is 3z plus z is 4z, so same. But here we can take factors, like I can take z common here. Z take common 1, sorry, z plus 1, right? And I can take 3 common here. I get z plus 1. Simple. Now these two are common. I take it once, z plus 1 into z plus 3, because this acts like z. So 3z plus z is equal to 4z. So 3z plus 3 plus z is 3 plus z of this z. Okay. So this addition, that coefficient is multiplied to this variable. This acts like a variable now. Okay. So now this would be, like this. Let me show you. Z plus 3 into z plus 1. Now, since it is quadratic, we first take a plus z, a by z, then b by z square, then plus c by, so we break this fraction. We would take this one times, this one time, this one time, denominator. And we want to know, like how this whole fraction is same, like when we take individual denominators. Okay. So when we equate this, then we will find that, we would know that, right? And we are writing our condition, z plus 3 here plus d z plus 1, right? So now, like we would take LCM. In LCM we multiply this into this, then do this. Okay. Now we would to get this. Okay. So a, what do we not have in this? We would multiply all this, then other denominators, so that our see, in numerator, if something is a into b, wait a second, right? No, wait. A into b plus b, no, d by b. Then what we do? We do a into b and c into b, numerator denominator multiplied, same thing, common factor, so it is same. We can cancel it later, divide, same thing, we get 1, because one part taken from one thing, still 1. And here we can do the same thing, c, then this became cb, this became cb. Common denominator, we can now write it common, and we can add this, so we can operate. So we do same thing here. Okay. The any variable that is not there, we would multiply it, so that it can multiply here, and every time, in every term it would happen same, and we get common denominator, this stuff, then we can cancel them both. Okay. So let me do it. So z square into z plus 3 into z plus 1, now plus b I would have to erase this, sorry. If you had to take notes or something, then apologies. So now, to make space, I had to erase it. So, b has z square. After a was an extra variable we took because it is square term. So we had to take an extra variable. Only here we had to multiply these three. Now when we take other three variables, we have to ignore this, like it doesn't even exist. We have to check among these what we don't have. So b has z square but doesn't has these two. So I would multiply these two, not z. Okay, z plus 3, z plus 1. Now plus c, z plus 3, no, z plus 1, because z plus 3 is in itself, so in its denominator. So z plus 1 and z square is missing, so z plus 1 z square plus d has z plus 3 is not there, z square is not there. Z plus 3 z square, here we go, by whole divided by z square z plus 3 to z plus 1. Here it is also same, 4z plus 3 by z square, z plus 3 into z plus 1. So now this gets cut with this 1 1, because same things, opposite side, same denominator would get cut, because it, if it comes here, it would multiply and this would divide, same thing, so it would cut into 1. Okay, 4z plus 3 equal to ez square z plus 3 z into 1, z plus 1, b plus z plus 3 z plus 1 plus c z plus 1 z square plus d z plus 3 into z square. Now let's take z equal to 0, because let me show you, wait a second. So yeah, in c, for so each time we have to take such a variable that others all become 0 and one variable remains, so that we find what it is. Okay, so uh, here we are, since we so for other two becoming 0, so you have to take one variable like that you want to make remove, like c, and if I take c, if I take its one variable like z square equal to 0, I take, then z equal to 0, then c has z square and this has z square, these two will be removed, which had z square, which since b had denominator z square, now it doesn't have any z square term, so that would remain and we would find what is b. Okay, so these two are removed, so z equal to 0. So like if I would have done for this, then opposite of 3 would have come and I have put it in here, then minus 3 plus 3 would have been 0. So this would have cancelled, z plus 3, this would have cancelled, only c would be remain and we would have to find c. So like that. So now we are taking z equal to 0. So 4z plus 3 equal to a is done because z square is there, so it is 0. Only b is there, this would be removed, this would be removed. Z square, where there is a z square term, that would be removed because it is 0. So b z plus 3 z plus 1. Now z equal to 0, no, so take it 0, take this also 0, then 3 into 1 is 3, so 3b is equal to 4 into 0 is 0, 0 plus 3 is 3 plus 3, so 3 by 3 is 1 is equal to b is equal to 1. Now we do same with others, like we would take let's say z plus 1 equal to z plus 1 equal to 0, z plus 1 equal to 0. Now z is equal to minus 1. So if I put this minus 1, then which would be omitted, like b term will be omitted because z plus 1 is there, minus 1 would be here. minus 1 plus 1 is equal to 0. So this would get cancelled. 0 into anything is 0. This whole is gone. Now z plus 1 is here in C. This would be gone. Only D would be remain. We would have to find that. So now 4z plus 3 is equal to D into z plus 3 into z square. Right. So uh, for z equal to minus 1. Right. Then we would take minus 4 plus 3 is equal to D into minus 1 plus 3 is equal to into minus 1 whole square is 1 into 3 minus 1 is 2. D is equal to minus 4 plus 3 is uh, minus 1. 4 is greater, so 4 has negative sign, so 4 sign will remain, which is negative, and for we would do 4 minus 3, they would clash and reduce, so 1 would remain. 4 minus 3 is 1. So yeah, now only greater number sign remains, otherwise it is normal subtraction. We take one apple from three apple, four apple, then it would be three apple. Okay, that's that, like that. Like in number line, if we this is 1 1 2 3, 1 plus 3 is 4, right, like that. Now 2D is equal to minus 1, then D is equal to this is in multiplication, here it would come in division. In multiplication, so here it would come in division, minus 1 by 2, like that. Now wait a second, let's take z, like here z plus 3, z plus 3 is only remaining, z plus 3 equal to 0. Let's take equal to 0, z is equal to minus 3, then which would removed, z plus 3 is here, z plus 3 is here, so plus 3 minus 3, or we took opposite, right? Like on in RHS we took it, so it became opposite negative sign, so opposite sign thing would be here, so it would be 0, so 0 into anything would be 0, and this term would vanish. Minus 3 plus 3 is 0, minus 3 plus 3 0. Only C term would remain, right? Only C term would remain. So let's try. 4z plus 3 is equal to C into z plus 1 into z square. So z plus 1, C into minus 3 plus 1 into minus 3 whole square is equal to 4 into minus 3 plus 3, which is minus 12 plus 3 is equal to 3 minus 3 plus 1 is minus 2C, minus 3 square is into 9, minus into minus is plus, so minus 12 plus 3 is also minus 9, so let's take it here, minus 9 is equal to minus 2C division. Here it is divided. Since multiply and divide are opposite thing, would be whole one would be taken, so division means how many parts taken, right? So yeah, this is minus 1. Now minus 1, this is here in multiplication, would go in division, right? So that would be, then C is equal to minus 1 by minus 2, then it would be 1 by 2, right? That's how we do it. So we found A, B, C. Okay, B, C, D. Now we have to take a random variable so that we have A. Now to find A, what we do is, let's take anything as Z. Okay, then we would find the whole thing. We have to put B2 and D2 and C2. Uh, okay, let's go. There is no space, that's the problem. I hope you remember all these, right? Let me do this. Let's adjust space somewhere. It is okay, right? So let's take z equal to minus. We have taken minus. We have to take different from these so that a doesn't get cancelled, because a has all three. So 4z3 is equal to uh okay, a1 square. Let's just substitute 1 in place of z. Okay, a1 square into 1 plus 3 into 1 plus 1. Now b we know is 1, so plus 1 into z plus 3 is 1 plus 3, z is we taken 1, so 1 plus 3, 1 plus 1 plus c, we know, we have found out it is half. Okay, we would write half here instead in place of c. Then 2 plus 1 okay, z plus 1, so that is 1 plus 1, then 1 square plus d we found out, which is minus half. So it would be plus minus minus, opposite signs, minus half into z plus 3 is z is 1, so z plus 3 is 1 plus 3 into z square is 1 square. uh, so we have to calculate this whole stuff. 4 plus 3 is 7 is equal to 1 square is 1, 1 plus 3 is 4, 1 plus 1 is 2, 2 into 4 is 6, 2 into 4 is 8, 8a plus 1 plus 3 is 4, 1 plus 1 is 2, 2 fours are 8 into 1 is 8, half. So 1 square is 1, 1 into 1 plus 1 is 2, 2 into 1 is 2, 2 by 2, half. So is the numerator by numerator, numerator into numerator, denominator into denominator. You have to separately multiply. Just write it. Okay, that is fraction into fraction. So yeah, let me just rub it. So this is 1 plus 1 is 2, this is 2 into 1 2, 1 square is 1 only, anything multiplied by 1 is 1. Yo, one person, thanks for coming, and I guess you left, so bye, have a nice day ahead. Oh, you are there, thanks man. Thanks, lovely person, such a lovely person. You came to make my life lively. Thanks for that. So 1 plus 1 is 2. 2 by 2, it would be 1. By the way, sorry, I'm really sorry. I'm really apologetic that I abandoned midstream, because today internet fluctuations are way too much, and yeah, sometimes things come up, so I have to go to attend them. So yeah, I'm really sorry. I abandon midstream sometimes. I'm really sorry. I deeply apologize. Kindly forgive me. So yeah, where were we? Yeah, minus half. Wait a second. Do the calculation here only. 1 square is 1. 3 plus 1 is 4. 4 into 1 is 4. 4 by 2 is 2. 2 into 2 is 4. So, and 2 into 1 is 2. 2 by 1 is 2. Because if numerator is how many parts you take, denominator is how many total parts are there. If there is one thing and I take two things, then I have so there is one part of a thing and I take two things, so I take two whole things, two into one, like two into one things, and it is not divided only. So I take the whole, like let's think about cake. So I take the whole two cakes because it is divided by one, so it is not divided, so it is full complete. It is not, it is not even divided once. Okay, yeah, because anything divided by one is that only multiplicative identity. Yay. So 8 plus 1 minus 2 is 7. Okay, 8a plus 7 is equal to 7. 7 7 9 is same on opposite sides, this would go with opposite sign. so they would cancel anyways, because 7 minus 7 will be 0. So 0 equal to 8a, then a is equal to also 0. A is equal to 0. Now we found everything. Here we can have, so let's write it in fraction form. So a is 0 plus b by z square. Wait a second. B is equal to 1, right? 1 by z square. 1 by z square plus c by, oh sorry, c we knew it is half by z plus 3 plus d is minus half by, this lecture forward later, because I guess there is no space in board also, and let's complete it. Forget it, let's complete it. Okay, I might erase something, but okay, let's do this. I would like to erase this part, dot part. So 0 plus 1 by z. So let's only do first question. Okay, wait a second. Okay, so let's do second one. Okay, 1 is smaller than z is smaller than 3. So z is smaller than 3 and z is smaller than 1. So now z plus 3, right? So here we would take, wait a minute, we would take 3 common, I guess. Mm-hmm. Yeah, we would take 1 plus x raised to n, right? Wait a second. So, okay. Yeah. This is 3. So, in z square, I don't think so. There would be any series. Let's say 0 plus z square. Is there any series? No, I guess. Let's do this one. Okay, 1 by 2, 1 by 2 z plus 3. So we have to take, so 3 z waited to connect, I guess. Yeah, it came. So which is greater, we take that outside, so that we get 1 plus something format things. Okay, so we took 3 common, then 3 by 3 would be 1, so we get 1, and z by 3. So we can also write plus z by 3. So like that we would write this too. uh, I would take 1, let's see which is greater. Z is greater, so I would take z out common. So okay, let's go. So this won't be plus, this would be minus actually, because this is minus half. Minus half, then this would be, I would take out z, like I would divide it in both sides, right? So z by z is 1 and 1 by z is 1 by z. Then here 3 by z by 3 is z by 3, and the 3 by 3 would be 1. So yeah, we take common multiple out. Like whatever we take out, we will, because it is gonna be later multiplied to the whole thing separately. So we divide it separately too when we take it out. So the question doesn't change, but we get our convenient format. So now we have so anything raised to minus 1 is, sorry, anything raised to minus 1 is 1 by a, right? So this is half multiplied by 1 by a, right? Numerator into denominator, numerator into denominator is into denominator numerator by numerator into numerator by denominator into denominator is fractions multiplication. So 1 by 2 into 1 would be remaining same 1 by 2. So 1 by 2 into numerator 1 by 1 into denominator 3 by z, which whatever it is. So it would stay the same one half by that. So if that stays the same, so we can write it like this, and now we can use this in our power series, and this half would later multiply. Okay, we can keep it in multiplication. So here also it is same, minus half into 1 by this. Now instead of writing 1 by this, I told you we can write it as power minus 1, power minus like in when we divide, I told you like a raised to m in divided by a raised to n is equal to a raised to m minus n, because division means, because division and multiplication are opposite, and power says how many times we multiply by it. So in minus power we say how many times we did it, right? And when it is in fraction power, then it shows how many roots we are taking, cube root, square root. Okay, so now we can also write it as z into z plus 1 by z whole raised to minus 1, and this can be written as, wait a second, half by z, this is half by 3, right? So we can write it as z, wait a second, z, z by 3 1 plus z by 3 raised to minus 1, and we have minus 1 formula here, right? Raised to minus n formula here. So now we can write it as I have to erase something now. Let me erase this. Okay, I guess you know the fraction, right? Now it would be numerator's denominator is denominator, so 1 into 2 into 1 by 2 into 3 is 1 by 6, 1 by 6, then this would, what have I written? Okay, z plus 1, right? Okay, that's kind of interesting. So this can be also written as 1 by z plus z. So 1 by 6, this can be written as 1 plus z by 3 raised to minus 1 can be written as, here it is given, 1 plus z by 3 z by 3 whole square, wait a second, this is square, this is cube, I wrote wrong, square, this is cube actually, this is 4, yes, and so on. Okay, now about this, minus 1 by 2z, let's write it. Okay, yeah, wait a second, this is 1, right? 1 plus 1 by z, no? So no, then why it is like this? 1 plus 1 by z, no? Yes, so 1 by 2z, numerator denominator is denominator, 1 by 2z into this stuff again, 1 plus 1 by z plus 1 by z whole square plus 1 by z whole cube, and all that stuff ahead. Okay, now you can also add that to like z square stuff, So 1 by z square would be 1 by z square plus 0. I don't know if something is like that, but yeah, let's just write it 1 by z square. Yeah, have fun. So, wait a second, what was b? Yeah, 1 by z square. Yeah, so this is how we found it. You can take screenshot or something, take notes. So we have found the Lorentz series of this function. Thanks for watching. Like to subscribe. See you next time. Thanks for watching. And sorry, I abandoned in mid lecture because you know light issues. So yeah, thanks for watching. See ya next time. Bye bye.